Hello, everyone, and welcome to the research results presentation. My name is Mike Fitch with the Ohio LTAP Center here at ODOT, and we appreciate your participation. As we get started, please take a moment to locate the questions box in the GoToWebinar panel. During the presentation today, please use the questions box to send in any questions you might have, and there will be time at the end of the presentation for discussion of questions. With that, we will go ahead and turn things over to Dr. Munir Nazal. Hello.
Hi, thank you, Mike. Good afternoon, everybody. Today I will be talking about the project on determining bond strength of microsurfacing mixes, phase 2. I would like first to acknowledge my co-principal investigator, Dr. Sang-Soo Kim, and Dr. Ala Abbas. And I would like also to thank ODOT and the Federal Highway Administration for funding this study. I would like also to thank the Technical Advisory Committee, basically that are listed here, as well as the Office of the Highway Infrastructure Management, who helped in this project. And I also want to thank the project manager for this project, Ms. Vicky Faut. So basically, the outline, I will be having first a little bit of a background, basically explaining why this project was initiated, then the objectives, and then I will be talking about the testing program, the results, and the conclusions and recommendations as part of this study. As you know, microsurfacing treatments had been used by several DOTs, including ODOT. ODOT, I think during the last decade or so, saw an interest or more interest in using this preventive maintenance, mainly because it's extending the service life. If we look at a recent survey that we done, it's a national survey, we can see that more than 50% of DOTs are currently using microsurfacing, which again indicates that it's one of those surface treatments that is widely used in the United States and by DOTs. One of the things that DOTs are not in agreement about is really placing a tack coat prior to placing or installing the microsurfacing layer or layers. In a survey, national survey that we did in 2019, that we had a question about that, and we found out that basically about 46% do not use tack coat, and that was in 2019. And the rest, which is a little bit over 50%, use it all the time, or sometimes it's also split. About 28 said that they use it all the time, use tack coat all the time, and basically about 25 said that they use it only in certain cases, typically whenever they have a highly oxidized or aged basically pavement or existing pavement. Now, some professionals, industry professionals, argue that really tack coat is not needed. Basically, since the microsurfacing mix has emulsion, the emulsion in the microsurfacing mix will be good enough to establish that bonding between the microsurfacing layer and the existing pavement. Basically, this argument, if it is true, or if it was true, then basically it can have a lot of saving in time and money, both for ODOT and basically the other DOTs. But of course, if it was not true, then basically that means that we have a risk of a premature failure, which can cost ODOT a lot of money for repair, and also will not really help in extending the service life of the pavement. And basically this will end in resurfacing the basically the doing a reinstallation of the microsurfacing mix. So so to answer really, so this project came really to answer one main question, which is, do we really need to apply tack coat in a microsurfacing application, and what really the benefits of using the tack coat? How does it affect the bond strength between the microsurfacing layer and the existing pavement? Also, if it is really needed, then basically as part of the project, we wanted also to determine what will be the optimum application rate, and as well as the type of micro tack code that should be used to ensure good performance for the microsurfacing application. One of the things is that this study is really the first study in the US to address the interlayer bond strength of microsurfacing, and therefore we had to develop a standard procedure for evaluating the bond strength of the microsurfacing mix. There's a lot of procedures for evaluating the bond strength between asphalt layers, but microsurfacing is a little bit different, and therefore the test procedure should a new test procedure should be developed, and that's was one of the objectives for that. So we have a comprehensive testing program. I will be really this is a 3-year study, so we had a lot of testing, but I will be focusing, because we have maybe about 40 minutes 45 minutes to go through the this basically project results. I will just focus really on the main things, and again, there is a final report that you can go to if you want more details about the testing program. So the testing program, we had mainly a field testing program, and I'll be talking about that field testing program in a moment, as well as a lab testing program. The focus really was to evaluate the tack coat application rate, and I'll be talking about what rates we have evaluated in a moment, the tack coat material type, as well as one of the things that is we knew, which is the microsurfacing mix emulsion content, and if it really affects the bond strength between the microsurfacing and existing pavement. And the last is really the existing pavement condition. So we had a field testing program, and I will be talking about that in a moment, where we constructed field test sections. And then basically we did a lab testing program. I will just briefly discuss the lab testing program. It was really to complement the field testing program and really confirm the results that we had there. So the field testing program, which is the main really focus of this project, we had 25 test sections. They were constructed in 2 projects. The first project was in District 3 on State Route 3. And then basically the second project was on in District 7, and it was on State Route 274. One of the things here is basically in district in the first project, which is on State Route 3, we had 14 test section. The first 7 test sections where we applied a single course microsurfacing basically a layer, and you can see here how we use 2 different types of tack coat material. The CSS1HM, which is the typical, or the one that are typically used for microsurfacing application, because it's the same really emulsion used in the mix itself. And then the SS1H, And then basically this is the tack coat diluted rate we used, as you can see, 4, including no tack coat, or basically a tack coat application rate of 0, and then we have it 0.03, 0.06, and 0.1. And again, this is what we targeted, but what we achieved was a little bit different. And when we go to the results, basically you can see the differences. But in general, for this project, the basically target tack coat application rate and the basically the measured were very close. And then we had also one important thing, which is the binder content or the residual binder content in the mix. We used the JMF, which is was 7.8, and then we used 0.75 less than that, so that still we were within the specification, within ODOT specification, at least at that time. The specification changed, which I will mention that, but at that time, which was in summer of 2019, the specification was, I think the minimum was 7.0. So basically, those are what we had for the first 7 sections. The last 7 sections, which you can see here, we used a double course microsurfacing sections, and basically what we varied very similar. We used a different tack coat application rate, and then we used a different material. But the main difference now that we also used basically an application. We used sections where we had different application rate between the leveling course and the existing pavement, and then also we had basically a different tack coat application rate, as you can see here, between the microsurfacing layers, the surface course and the leveling course. And again, we used a different binder or a residual binder content in the mixes. The project on State Route 274, we had 11 sections. We had a different tack coat material type, as you can see, very similar to State Route 3. We used the SS1HM and the CSS1HM and the SS1H. And then basically we had different tack coat, very similar the 4, which is 0, 0.03, 0.06, and 0.1. And again, we had also here used a different basically residual asphalt binder. We used the JMF in most of the sections, but we had basically 2 sections or 2 sections where we used a lower binder content, about 0.7. The reason why we used 0.7, not 0.75, because we didn't want to be below or out of the spec. The minimum at that time, as I said, is the 7. And we did also evaluation on the road condition. So the field testing started by basically evaluating the pavement. We tried to look into the surface texture. We did the sand patch. We did also dynamic circular test, and then we took cores, and basically scans were done using the AIMS as part of the Highway Infrastructure Management Office. They helped in that. And basically during or prior to construction, the day before construction, we calibrated as you can see here, we calibrated the trucks, the distribution, the tack coat distribution trucks, and basically we calibrated so that they can hit the target. In State Route 3, we were successful. In State Route 274, we were less successful, but still, I think in some sections we were able to hit the target that we want. So we monitored the construction, made sure that there were no issues during construction. And then after construction, we went after 1 week 3 months and 12 months, and we obtained cores, and basically during we obtained the cores, and we went to the lab and tested them, as we will talk about it, and then basically we did an evaluation through that time. The lab testing programs that during the field projects, what we did is we collected aggregates and emulsion. So we really replicated the testing matrix that we had in State Route 03, but now using basically HMA mixes that we prepared in the lab. Again, there is a testing procedure, a special testing procedure to simulate basically what's happening in the field, but I just, for the sake of time, I don't want really to go in it. But if for those of you who are interested, they can really go back to the report. It explains the step-by-step procedure that we did basically for preparing samples and testing the bond strength in for those samples in the lab. Now, for the core samples as well as for the lab samples that we prepared, we did 3 different tests, 2 types of pull-off test, and I'm focusing here on one of them, which is the project shown in the figure here, and then a torque shear test that we developed as part of the study. We did not really find something specific that can or a test that is specific that can be targeting the torque shear test, which is again give us the one of the modes of failure in the field for debonding, and basically the torque shear test. This again testing procedure is it's a very simple device that we developed, designed and developed basically as part of this study. So I will be going through the results. So I will focus on the what we had, the torque test results or the test results after basically 12 months. And what we have here is basically, as you can see here, for the those sections, we can see that after 12 months, we can see that there was a difference in the bond strength in terms of the torque bond or torque force of the sections with tack coat as compared to those without tack coat. The lowest basically bond strength was with the section 2, which is the section without any tack coat, and basically the next section or the next lowest section is basically the one with a lower residual asphalt binder content in the mix. So this is an indication that again, no tack coat will result in lower bond strength, and also the lower or using lower residual mix content close to about 7. This might also result in a lower bond strength between the microsurfacing layer and the existing pavement. We can see here also that the highest really value were obtained with the highest emulsion rate or application rate, especially when we're using the CSS1HM. So one of the things that I would like to note, and you will see that later on, is that in certain sections, when we got the core, it seems that the existing pavement had some issues, and basically not at the surface, but within maybe 1 inch or a couple, an inch and a half. And that basically when we did the torque test or even the pull-off test, as you will see, basically the failure occurred within the HMA mix. So those results, because that's a problem in the mix itself, we did not really include in our results, and I'm not showing it here. If we look at the statistical analysis that we did, again, the effect of the section properties is significant at 95%. The ranking that we see here, again, it's clearly that the sections without tack coat and the section with basically a lower asphalt, residual asphalt binder content in the mix, those are the lowest in this case in terms of the torque. As you can see here, it's clearly the one with the no torque coat. And again, you can see that the sections with a tack coat are significantly higher, especially the ones that are really above about 0.055 a tack coat application rate. This is basically where we see that it's statistically significant higher, or statistically higher significantly as compared to basically the no tack coat. If we look at the ProSec, very similar results to what we got in the torque. The main difference, I would say, is really that we observed section 1 was slightly higher than section 2. So again, not using a tack coat is basically resulted in the lowest bond strength, and it was basically much lower than the other sections. And then the section with a lower residual asphalt binder content basically had a lower bond strength as compared to the other sections with tack coat, but with the typical residual content of about 7.8. Statistical analysis is again very similar to what we have in the torque. So there is really no difference here. One of the things that I want to mention is that the increase of the bond strength with time, we notice that it increases with time, typically within 2 to 3 months or 2 to 4 months. This is where the highest increase, but after the 4 months we do not really see any increase in terms of the bond strength. So and you can see here where you can see the 12-month and the 4-month are very similar. In terms of the type for this section, we can see that really there was a significant difference between the application rate, between the low and the high. But when we're talking about the low, we're talking about less than 0.03, and then the high, which is basically the around 0.1. So there's a difference there. In terms for this, there is some difference between the different tack coat types, but it is not really, at least in this basically project, or it was not really significant. Now, if we look at the double test sections, and basically this is the results for section 8 to 14, what we see here is that the section with no tack coat, whether between the existing pavement or basically between the microsurfacing layers, we see that those are lower than those with a tack coat that have been applied between the existing pavement and the basically a microsurfacing layer. So we can see that really we have two groups. From here, it seems based on the torque that the sections that have at least a 0.03 or 0.028, as you can see here, basically application rate between the microsurfacing layer, and at least a 0.055 between basically the existing pavement and the leveling course. Those sections where it seems to have a significantly higher bond strength as compared to the other sections, and those sections we are including really the section with no tack coat at all, or basically a section with tack coat between the existing pavement and and the leveling course, but no tack coat in the second layer. And again, the statistical analysis is confirming that. We can see that really those those 4 sections or 3 sections, those are really the ones that are statistically higher or have statistically higher bond strength as compared to the others. So this is an indication, based on the torque at least, is that using a tack coat between the microsurfacing layers seems, at least a minimal amount, which is about a rate of 0.03, seems to be helping in the bond strength when it comes to double course or double layer, basically a microsurfacing application. Prosic is very similar, but what we have noticed is really the difference between the sections with a tack coat between the microsurfacing layers and those without. The difference is still, we see some difference. It's basically adding a tack coat between the different microsurfacing layers will help, but basically it is not helping. It is not increasing, or the increase is not as significant as the one that we have seen in the torque test. And again, you can see that here from the statistical analysis, which is, again, it's really showing that you have really the 2 sections that are high, but the other sections are, again, there is some differences. And mainly we're seeing that the sections with a low microsurface, a low residual asphalt binder content, as well sections without tack coat in either layer, seems to be lower, especially if you have no tack coat at all applied. If we are looking at the 274, again, it's only a single layer. And basically what you see here, again, very similar results to what we have in State Route 3. The main thing here is that, again, the section with no tack coat has the lowest bond strength, and it's significantly lower than the ones with a basically a tack coat of 0.05 or higher. This is basically what we note, especially if you're using a CSS1HM. This is basically what we have. And basically, if you look at basically the statistical analysis there, you can see that those those that have the highest tack coat application rate with the CSS1H basically they have the and or the SS1H, basically those are the highest. They have the highest torque bond strength. And in this section specifically, we have seen that the SS1HM, there is a difference really between the two different between the two tack coat material, and really because for this project, the CSS1HM was a little bit stiffer than the SS1H, and that might have resulted in a difference in a higher, basically, a bond strength that we have observed in basically in this study. And again, this is the statistical analysis. You can see here that really now the difference between the materials is statistically significant. So again, that is an indication that, again, the material type, which we expect have a significant difference, but again, it only have a difference if really we're using a much different properties, or basically much stiffer maybe a tack coat as compared to a softer one. Again, we are seeing here also that we are seeing a difference between the application rate between the medium and the low. Basically, we were able also to see that that difference is statistically significant. The Prosic, very similar results, I would say. And again, one of the things that we noticed here for the process, again, the lower residual, mixed residual asphalt binder content, we're seeing that this was the lowest, had the lowest bond strength. So it, and again, following that, it was really the section with no tack coat. So again, having no tack coat or having a low, basically low residual asphalt binder content, and also using a low basically application rate, that combination might cause a lower bonding, and it might cause delamination or debonding issues in basically for those sections. Again, the statistical analysis here can basically you can see that, and you can see basically those that 1A and 11, those are the ones that have basically the main issues here. And one of the things that I would say is that any sections that were removed from here, it's really mainly in the statistical analysis, they were removed because of failure in the core. Mainly, there were two types. The first type, which I mentioned, is basically a failure in the HMA itself. There is another type, which is sometimes when we did the core, it was really hard to determine whether it is on a seal coat, and sometimes we had those cores where we had it on a seal coat and basically a sealing coat, and basically that resulted in problems in the testing. So we had to not include those results as part of our test. One of the things that we try to do is really looking at the texture and the surface texture. It was really hard to do it in the field because the surface texture really across even a 900 feet section, it's really, or 1,000 feet section, which is the typical length that we had. It was really hard to determine. So the best thing that we did is we obtained cores prior to construction, and we looked at, we used basically the AIMS scanner, again, the Office of Highway Infrastructure Management helped in that. And basically what we did is we looked at the AIMS, and you can see here that texture measurement, the mean measurement basically. And what we did, we tried to group, again, use the statistical approach to group those cores, and we used the cluster analysis to do that. So we were trying to see ones that have medium, high, and low texture, and again, statistically those were different. And then basically what we did, we prepared samples using the same materials, emulsion and aggregate, and then we tested those, and we looked at what is really happening. And you can see here, we do not really see any difference between the three groups. Difference is very small, and again, I'm not showing the statistical analysis, but at 95% or even at 80% confidence level, those will not be significant. It's basically they will be same, especially in the torque. The Prosec pull-off test saw some differences, but really not much between the group 1 and 3, but still it was not statistically significant. One of the things that we wanted to do here is how can we relate those bond strength to performance. We looked at the Office of Pavement Engineering provided us with basically the PCR data for the microsurfacing, and we looked at a certain code for the debonding, which is code 4, and we found out that in general there is really no issues in the microsurfacing layers that were installed in Ohio, and that makes sense because again, in all of those sections, or the majority of those sections, a minimum of 0.06 application rate is used. And again, based on our result, that that application rate will ensure the bonding. But what we did really to see if we can relate the bond strength to the performance. We looked at different sections that were constructed through the project, and we took cores at several sections, including, again, the test sections that we have. And then we were also able to have a section that failed prematurely about after 3.5 months after construction on State Route 89. And basically what we did is we located where we had a severe delamination issues or some delamination or no delamination, and basically we took cores from all the entire section and we tested them. So if you look here, this is comparing the basically different sections from different projects. Again, the ones on 274 and 03, we selected the sections that are closely or as close as possible to a 0.06 and a mix properties, the typical mix properties that we have. And what we noticed was, again, that the torque was able to distinguish between the to detect really the debonding, the field debonding. And you can see here it's really statistically significant lower. It's really significantly lower than the other sections, especially, again, those two sections. And basically this indicated that really we have a minimum of 225 torque in order for us really to have a good performance. And again, at least those sections were there for at least 2 years without really any issues, and therefore we're confident that basically at least within the first 2 years there is really no debonding. Now, I'm not showing that, but when we did the analysis only for those three, we were able actually even to detect that this section, which did not have any at least premature debonding at that time, was significantly higher than the other two that showed debonding. And again, this is an indication that torque test is giving a bond strength which can be related to the performance. And again, long-term performance evaluation should be conducted to confirm that. The PROSEC is the same. The only thing is we were able at 125 really to separate between the good performance and low performance. One of the things that I would say is that the torque seems to be more was able to be more sensitive to the variation in the bond strength as compared maybe to the other sections. So from here, the main conclusions that we have, it's clearly that at 95 confidence level, we can see that the sections with no tack coat had a significantly lower bond strength as compared to those with at least 0.06 total application rate, or 0.01 basically residual application rate. The results also indicated that at 95% that the use of a 0.75 lower residual binder content have resulted to significantly lowering the bond strength between the microsurfacing and the existing pavement. We have seen that the tack coat application rate, it's important, but once you hit the 0.06, we're starting to see that the effect of the application rate is not that significant. So we did not really see a difference between the 0.06 and 0.01, or a significant all the time, I would say. When it comes to double microsurfacing layer, we're seeing that adding a tack coat between between the leveling course and the surface course seems to improve the bond strength, at least from the torque test, but that did not really was not the case when it came to the pull-off test. And again, a very important thing is here we're talking about a much lower application rate of 0.03, not the 0.06. So something, I would say a lower application rate might be something to that will help in improving the bond strength. So as the recommendation, again, we're recommending that basically ODOT to continue using a tack coat. We're recommending that basically the specification with which requires a tack coat application rate of 0.06 to 0.12 to basically to continue on using that. We are also suggesting that to continue monitoring the long-term performance of the test sections, and based on that, making ODOT might consider really using a tack coat with a minimum of 0.03, basically between the microsurfacing layer. We're suggesting between 0.03 to 0.06 because higher than that, that might also cause issues. So it's really something that should be on the lower side application rate. But again, as I mentioned, that should really be based on the long-term performance of the sections on State Route 3. We have recommended, we made a recommendation that basically to use a minimum residual asphalt binder content of 7.5. Basically, this have been implemented in the latest basically construction and specification manual. Basically, this has been already basically implemented. So this change already been implemented, which is using a 7.5 as a minimum as compared to 7, because this seems to be affecting the bond strength and the mixture in general. One of the things that we recommend is that if ODOT in the future decides to use a performance-based specification, then basically we're recommending to use the ProSec and the torque. Both of those tests will cover the two modes of failure, which is tension or basically shear. And basically we're recommending that those tests will be done at cores that are obtained at least 2 months, because this is where most of the bond strength will develop. We're suggesting values, basically the minimum value, the average value of 3 samples should not be below 125, or basically it should be greater than 125. That's for the ProSec, and for the torque, we're suggesting it to be at least 220 or greater. And again, this is based on the data that we have in this project, you know, and those numbers might be changing as if ODOT decides to basically implement a performance-based specification, but those are basically a benchmark values that can be used at least to establish those specification. So with that, I would like to thank everybody for listening to my presentation, and I hope that our roads in Ohio will continue to be smooth, and we will have those cars running like this car. So thank you very much, and if you have any question, please let me know.
All right, thanks, Munir. We've had several questions so far. So in the chat box,
Yes.
I've copied the first question. It was at 2:17 p.m. from Andrew.
Okay. So I think the first question on the feed section, when I think it might be why you did not place a tack code. Did you measure the existing moisture on the existing pavement? So the first thing that we have in terms of, and let me go to maybe section 1. I'm guessing the question is about State Route. I'm guessing it's about State Route 3. We applied. We actually applied in section 1 a tack code. We applied for section 1 in State Route 03. We applied. Let me see if for 274 if we did not apply, I think we applied for both sections, attack code. We monitored the moisture, and we monitored. One of the things that I would mention is that in one of the sections, and maybe I will go there, there were basically water applied, and we actually looked at that effect of applying the water basically to there, and maybe if you can see here section 9 where we did a dry and wet, we monitored that, and we did not really see any difference, and basically that basically for that section, which again led us to thinking that there is really the differences were not statistically significant there. And let me go to question 2.
Munir,
Yes.
while we're on question 1,
Yeah.
Andrew just sent in a follow-up. He said, on slide 31, section 11, you did not apply tack coat. And then he says, was the surface dry or wet?
So 31 is okay, and
Slide 31, section 11.
section 11, yeah, we did not apply tack coat, and the section was there dry, because during it was actually that was the first section that where we applied, or we started the construction from that section. So we it was dry, and we did not apply in a tack coat because that's what we were comparing to. So we were trying to compare. This is our, I would say, control test section where we're comparing with tack coat to without tack coat, and basically that's why we did not apply, because we wanted to see if we did not apply any tack coat, what will happen. And basically this is what you know, that's what we observed, is basically the results is showing that there is a significant difference. So again, in both projects, section 11 was that no tack coat, so that was done because we intentionally did that so that we can compare. And in section basically 2, if we're looking at the state route 3, section 2, this is where basically we had no tack coat in both sections. So there is another question which is from Bobby. It's was the residual content of the tack coat controlled or unknown? We took samples, and basically we tested the residual content. So basically, I'm not showing here. We actually we actually tested the residual binder content or emulsion content. We took several samples during construction, again within a sealed containers, and actually the Office of Material Management did their own testing, and we did our own testing, and basically we have a record of what was the residual content or binder content for the tack coat. So that was we have documented that. So let me see, is there question 3 from John? Was the residual rate of the microsear verified in the field? I think well, I think there is the ODOT have their calibration, and that calibration was done the day before, and that is basically how I think ODOT verifies the mixture, basically binder content. So we made sure that basically the mixture binder content you know, the values were the correct values in terms of like the machine, but basically the verification of that, there's a ODOT have a procedure to do the verification before the day before that, and again that calibration happened for each project separately, of course, the day before construction happened. The question 4 from Chris: was there any pull-off of the diluted tack coat on the tires of the paver? That's a good a question. There were in certain cases, and we monitor that, but it seems it did not really effect, or that effect was not there. But again, one of the things is what we noticed is using a CCSS1HM as compared to the SS1H, the using a stiffer binder, the pull-off basically is will be what we noticed is less, and basically that might be one of the reasons why, again, in one project we had a significant difference in terms of sections with a CSS1HM as compared to the section with SS1H. But again, yes, pull-off happened, but again, it was limited, I would say, and basically it was less in the CSS1HM as compared to the SS1H.
Munir, a follow-up question from Chris. Is
Yes.
that where you cored?
Well, it was really, we cored always on the wheel path because we thought that we always cored in the wheel path because this is where basically the location where we note we think that, or this is we did some limited testing between the wheel path and the center of the lane, and we have seen that the wheel path will be more where the failure will happen, and therefore that's why we focused on the wheel path rather than the center. But is it the same? We cannot really tell if it is at the same exact location, whether the pull-off happened, because again, in the field we cannot control it. It might be, most likely it is, but we cannot really confirm that.
Okay, and we have a question 5 from John.
Yeah. The timeline was 7 days. So we so that I can so what is the timeline for applying the tack coat? First pass out tack coat and second pass, are we talking about so are we talking about the double, or are we talking about basically, I'm not sure, or are we talking about just the application? There is really no compaction. I'm not sure what is the first pass, or are you talking about the first pass of the tack coat? So if you can really send the text to clear it, that will be maybe better. But if you're talking about the double microsurfacing section, we had a week between the first layer and the second layer. In terms of the tack coat, we had basically waited about 10 to 30 minutes basically until basically the tack coat broke, and then basically applied the microsurfacing mix.
Munir, there's a
Yes.
follow-up from John. He said, typically you have to wait 18 hours between pass of microsurfacing. Did you wait for the tack to cure? If so, how long did it add to the paving process?
So, so 18 hours, are we talking about between the first layer and the second layer? I'm guessing. Well, for this special case, again, because again, this is a research study, we had to wait a week because we did a core on the first layer to start with, and then basically they had to apply the layer. But in terms of the waiting time, again, the waiting time was about again, because it was in the summer, the tack coat broke, I think, after 15 minutes, and then basically it applied after 20 minutes. Basically, the application basically we applied or the contractor applied them, installed the microsurfacing mix. um, there's a question, so I'm not sure, yeah, if there is any, like, if that answers the question, that's good. If not, maybe John can send a follow-up question. I think another question from Bobby: was the mix set additive used for this job? Does it seems possible that different section would have a variance in this way? So I would start with the second part. We did not use a set additive, and basically, as basically, the additives are, that's a typical additives that are being used for a microsurfacing mix, but not a special set additive. But in terms of there is really, the construction was done in terms of the mixing, it was continuous. So basically we applied the tack coat and the paver, then basically applied the microsurface. So I don't think that there is a variability or any variability between the mixes from one section to another. And then the other thing is that even in the results that we see is that even we have sections in two different districts, in two different by two different contractors, and still we're getting the same result. Now, when we did, and this is one of the important things, that's why when we did everything in the lab, I did not really see that, but actually the results of the lab, where we had it in more controlled environment, because we are mixing everything, and we're everything is the same, everything is the same, we got exactly, I would say, same result. So the lab, which is, that's one of the reasons why we did the lab testing, is that really confirmed what we have seen in the field. There was really no contradiction. The only thing that we have seen is basically the same thing, is that we have actually seen that the application rate basically have an effect. Applying a tack coat has an effect, and basically lowering the mix has an effect. And again, lowering the mix, one of the reasons why we went actually with that, we did some preliminary testing before even the field test section, and that's why we went to 0.75. So again, even if there is a variation in the field, we don't think that it affected the results, because again, both projects confirm the same results, and more importantly, the lab test results also confirmed what we got in the field. And again, the report will basically show that, again, because of the timing, I did not really want to go through the basically, because of the time, I did not really want to go through the lab test result. But again, the lab test results, it's really confirming what we have in the field. So there is really no contradiction. So yeah.
Munir, we have one additional question from
Yes.
Chris. He says,
Yes.
Did the pull-off bond test result in failure at the interface?
Yes, in the no tack coat, yes. Whenever we have in the no tack code, typically what we have what we refer to as an adhesive failure or a more adhesive failure when we don't have a tack code. Whenever we have a tack code, still it's adhesive, but it will be we tried actually to calculate that area, and it was, I would say, about 60 to 70% adhesive as compared to cohesive. And what I mean by cohesive, it's basically when you look at it, you still see some of the microsurfacing mix on at the interface. But in the no-tack coat, we have seen it's almost 90% to be uh, uh, basically adhesive. Yes.
Yeah, Chris has a follow-up. He says, any failures in micro during pull-off bond?
There are, but basically, uh, um, again, it as compared to again, there's we're talking about percentages, and that's why I'm saying the cohesive is failure within the mix, so that is the cohesive. The adhesive is basically failing at the interface. So we're saying that it's about 90%. 90% adhesive, typically with a no tack coat. With the other one, what we noticed is with a tack coat, it went to be around maybe 60 to 70%.
Okay, Munir, I've copied into the chat
Yeah,
a comment from Eric.
yeah. So basically, again, there was no special requirement. Eric is indicating to use a liquid retarding the additives in the mix. So basically, that's confirming what we have, and we do not require this. Basically, in Ohio, we do not require that. So we had neither mix set up too quickly in both projects. So that is again, Eric Beal is also confirming that. So thanks, Eric.
Okay, we have no additional questions at this time. Vicky or Munir, anything to add?
Well, just thank you, everybody. Thank you for the questions, and that's it.
All right. Well, thanks, Munir, for presenting, and thanks everybody for your participation today. We really appreciate it.